So before going to that, why this antenna comes, and one more thing, now go to the higher frequency. Why we will go higher frequency? So lot of reason is there. Because first reason is antenna. So we will go higher frequency because of antenna. So usually when we send signal, suppose there is a signal, the total signal, this is called wavelength for one periodic shape, it is called wavelength. Now to transmit signal, antenna should be, that antenna length should be lambda by 4, this is the lambda by 2, that is the thumb rule. Now if I am transmitting a signal, f is equal to 100, for example 100 megahertz, I am sending a signal 100 hertz. Now lambda equals to c by f, free space if I communicate, 3 into 10 to the power 8 by 100 hertz. Now this it will be divided by 2 antenna length, then it will be divided by 2 only. So 3 into 10 to the power 6 by 2. So 1.5 into 10 to the power 6. So 10 to the power 6 means 1 lakh. So 1.5 is closely 1.5 lakhs kilometer, 1.5 lakhs meter. So 1.5 lakh meter, it is a huge, a few kilometer. To transmit a signal, you need an antenna few kilometer. Suppose you are sending a signal to somebody else, then you record a big antenna, then you just, it will be very excessive cost and the antenna. Then if I increase the frequency, see, if I increase the terms, then this term will decrease. Now if I make to 100 megahertz, then 10 to the power 6 will come, then 6 2, then 3, it will come 3 meter only. So if I increase the frequency, then antenna dimension will be extremely less. So basic fundamental theory of high frequency, we are exceptionally going to higher frequency because of antenna, reduction of antenna dimension. Now question is, we already enjoying 2G, 3G, 4G. So why antenna extremely less? We have smartphone, and smartphone also we are not reducing the dimension, because display also we need a high quality display, long distance also, 8-inch or 6-inch display we required. So antenna is simply he put means clearly antenna वहाँ पे बैठ रहा है मोबाइल में, then antenna size with aspect to antenna size it is fine. But why we are using to high frequency? There is another terms, channel capacity. This is a formulation done by Shannon. This is called Shannon. So this formula tells C is the channel capacity, is the called bandwidth and signal to noise ratio. So for now signal to noise ratio, let it be, some signal we are sending, some noise will come. So this term we can ignore now. This channel capacity means how much signal, how much data rate we will get, how much data we will get, 1 Mbps, 2 Mbps, that is depends by bandwidth. What is bandwidth? Bandwidth is a frequency difference, f2 minus f1. For example, I am transmitting a signal. So I am sending a signal. So what is the bandwidth of the signal? How long I will send the signal? What is the bandwidth? If bandwidth is high, then I can share maximum data. Now in 3G, their bandwidth is very less, but in 5G you can see 3.3 to 4. So it is coming 0.7 gigahertz, means 700 megahertz. Now coming to the 4G band. So for example, let's take 1800 to 1900. This is the band. See, only 100 is available, 100 megahertz. But there is another tricks, and you can tell this is a government regulation, try regulates. So 100 megahertz you can't use at a time. because a lot of mobile carrier organization is there, and there are some government also sell some spectrum. So at a time 100 megahertz not possible, so small fraction they will sell to the respective मोबाइल कंपनी, तो रिस्पेक्टिव मोबाइल कंपनी को थोड़ा थोड़ा मिल जाएगा, उससे वो लोग को बैंडविड्थ भी बढ़ाना है, स्पीड भी देना है, अदरवाइज वी विल एक्चुअली कंप्लेन देम दे आर नॉट गेटिंग स्पीड. सो देयर इज ऑल कमर्शियल पर्पस इज देयर. नाउ 100 megahertz to 700 megahertz, 7 times increment. Can you remember? Can you imagine? So bandwidth aspect, too much increment, if government regulate the bandwidth also small, even though it is high. So we will get high data rate. Now if I get 1 Mbps, you will get 7 times, 10 Mbps, at least 10 Mbps guaranteed. So that's why if you go to higher frequency side, there is a chance of high data rate because of bandwidth. Now lot of thing will come, so high frequency lot of issue will be there, so it is not an easy job, so people are working too much different area. Now in this case again our RF engineer, all the things they will do OFDM multi-carrier path, so they utilize maximum, so how much they can do with the small bandwidth whatever given by they try. And you know that spectrum it is very costly for them, government, when the government auction the spectrum it is too costly, so they have to utilize their spectrum very cautiously, and they will do modulation whatever is extremely useful for their business purpose. Anyway, now coming to the picture, if you increase the frequency, no, so suppose this is a wavelength, so lambda equals to C by F. So once we increase the frequency, F in terms of F equals to C by lambda. So lambda will reduce. When you increase the frequency, lambda will decrease. So lambda is decrease means this wavelength will be here. So this is F1, this is F2. Now what happened? If I decrease the frequency, so noise will affect much. If your signal strength, you transmit some signal and you are suppose sending some signal at higher frequency, so higher frequency means suppose at 3 gigahertz lambda equals to C by F. So C is 3 into 10 to the power 8 by F equals to 3 into 10 to the power 9. So just 110 will come, so 3 come, so 0.1 meter. So means 0.1 meter. So 0.1 meter means 0.1 meter. If we multiply it by 1000, so it is 100 centimeter. So 3 gigahertz wavelength is coming 100 millimeter. 100 millimeter. So you remember one scale, one big size scale. This is 300 millimeter. So at 3 gigahertz this is the wavelength, this much. So if the wave comes to you, this is 100 millimeter. Suppose the wave is trying to penetrate, it will absorb actually. It is not an easy job. When wave will come, it will hit the object and it will attenuate. One more thing, some noise will come because of high frequency effect. So this, let me introduce this noise. If we increase the noise, then total this term will decrease and this term again decrease. So channel capacity will decrease again. So that is another issue, noise issue, high frequency. Now one more thing, now if I increase the frequency too high, then our signal will be destroyed and it will attenuate. Suppose if you can remember, you can check also in dish TV, whatever in terrace something will be there, you just put a leaf there, एक पत्ता नॉर्मल एक पेड़ का पत्ता वहाँ पे रखिए जो डिटेक्शन सिस्टम है, तो इमीडिएटली उसका सिग्नल कट जाते हैं, because the wavelength is very less, it can't, if you penetrate it, it will stop, the signal attenuated actually. Now why I am telling this much? Now we can in 5G there is a possibility of signal absorption. So there will be a huge change of tower in future to cover the things, and in outside I am not sure whether they are able to use high frequency in outside, because a lot of buildings is there, lot of trees there. So still they will use 2G here, 2G or 3G, that band they will use because of low frequency, below frequency, long wavelength. But inside home or small region they have to put antenna, that will solve the issue. Anyway, in this context I can discuss one more thing. Why still we use low frequency order of less than 500 megahertz? So that is VHF band, UHF band, that is less than 500 megahertz. So let us discuss this point also. In radio communication, Voice of America, one channel is there, Voice of America. In my childhood I have also heard. So signal one America, from America, whatever they told, we got the signal from India. So this is too far, still we getting the signal. So now come to the what is the wavelength of this signal. So usually medium wave frequency radio band, usually they use some for example 60 kilohertz, 600 kilohertz to 1400 kilohertz. I am not sure about this 600 kilohertz to this. So for example, let's example 100 kilohertz, 1000 kilohertz. So in this band the wavelength is in particular meter, kilometer actually. So lambda equals to C by F. So C is 3 into 10 to the power 10 to the power 8, F equals to 100,000 kilohertz, 10 to the power 3. So 3 and 6. So it is coming 300 meter. So usually they told some 500 meter band or something. So this is a 300 meter. When you are sending a signal, the wavelength of the signal is 300 meter. Now from America the signal is start travel. When he travel, there will be lot of hill, everything will be there, but 300 meter is sufficient. Suppose one hill is coming here, the signal is enough long, he will overcome the mountain. So if any big thing also come, the signal will cross the device. So there is a less attenuation is there, but we should give enough power in the transmitter to receive the at least some data. So this is the fundamentals why low frequency is still useful in military application, or suppose in there is no communication possible also, means some territorial issue, some jungle is there, then how will communicate? The high frequency may not works properly. So in that case मिलिट्री जो यूज़ करते हैं खुद का ट्रांसमीटर रिसीवर यूज़ करते हैं, तो वहाँ पे भी आपको लो फ्रीक्वेंसी में आना पड़ेगा. सो दिस ऑल अबाउट द फ्रीक्वेंसी एंड व्हाट अबाउट द व्हाई वी आर luxury about the high frequency. So two reason is there. First of antenna miniaturization, and another is channel capacity to increment the data rate.